Our next speaker is Dr. Cesar Corzo. Cesar holds a DVM degree from Colombia, and he earned the master's from the University of Guelph and a PhD from the University of Minnesota. He has worked for Elanco and PAC, and most recently, he is the Leman Chair of Swine Health and Productivity at the University of Minnesota, where he is the principal investigator of the Morrison Swine Health Monitoring Project. So many of you are in contact with Cesar on a weekly basis. Thank you, Cesar.
Thank you very much. Can you hear me in the back? Good, thank you. Thank you very much, Maria, for that introduction. And thank you all for being here for the 50th Leman Conference. It's exciting to see so many people celebrating with us the 50th anniversary of our meeting. So what I have planned for today is kind of fits in with what a lot of the previous presenters have told you, right? And I know that my name is on this slide, but I would be making a big mistake if I would not be acknowledging the team of individuals that have been involved in these two projects or the data that I'm going to share today. Because this has taken a lot of thought as far as, like Dr. Brad said earlier, we have a lot of biosecurity, but we continue to fail, right? And that's tackling that question pretty much. So some of you have seen this graph before, right? PRRS is cyclical at the breeding herd level, right? Fall comes in, we start seeing the breaks. As spring kicks in, the frequency of those breaks goes down. It does not disappear, right? During the summer, we'll continue to see PRRS, right? At a lower frequency. However, we got another wake-up call, right? And that wake-up call started in the fall of 2020, as some MSHIM participants started talking amongst themselves, comparing sequences. They told us, and then we said, what is going on, right? Well, that wake-up call started in the fall of 2020, and it kind of got more dramatic because then, for the first time in the length of the MSHIM project, we saw an important event during the summer. PRRS is not supposed to be a summer disease, right? And I'm always scared when we say flu is a fall disease or a winter disease. Diseases, yeah, what's seasonal, right? These diseases don't disappear, right? The thing is that there are lower prevalence or incidence. So this wake-up call was kind of pretty much one of the triggering factors for these two projects that I'm going to share with you today. As this started, we started characterizing these events, right? So Dr. Mariana Kikuchi from my team started understanding how quickly is this one virus that gave us this wake-up call, how quickly is it disseminating through the state of Minnesota or the surrounding states. But at the same time, at that time, one of Dr. Kim van der Wal's PhD student, Dr. Nakarim Pamon Chainavakul, I'm always proud of myself when I get to pronounce his last name correctly. He started comparing sequences, and he told us, yes, this is a whole new virus, right? So we have a new breed of viruses going through our farms. And this is the map of the very early stages of that outbreak. All these are sow farms. As they started to break, Mariana started putting all those on a map, and she was able to put the yellow dots, which is any other virus, versus the new variant, right? And as you can see, the fall comes and the red dots start showing up. That means a lot of transmission, right? And that's not of course, there's within herd transmission, but there's between herd transmission. And that's what kind of scared us, because of the speed of this transmission was kind of fast. We said there's something new about this virus. So this is when we started talking to others. Some of you in the room were part of this discussion, so thank you. And we started generating questions, and we started asking ourselves, what are we missing? Dr. Brad said it. He kind of stole a lot of my ideas. So Brad, you and I are kind of on the same page. And that's when we started thinking, let's take the dirty hand approach. Are my hands clean or dirty? If I look at them right now, they might be clean. If I get some samples and go and run some tests, I would be pretty wrong, right? So we said, okay, when it comes to PRRS, we know that yes, in a barn, there's gonna be infected pigs, there's gonna be shedding all over the place, but how easy it is to find it, right? So we went to the Swine Disease Eradication Center. We talked to Maria. We said, Maria, I think this is a concerning project. Hey, consider this. Why don't we work together and try to get some data, right, to start us off? And this is where I need to give credit to my PhD student, Marcelo Malini, who is somewhere in the audience. He presented yesterday in Spanish the same information. And that's when we started thinking, what's the approach, right? How do we test surfaces? How do we collect samples? How many samples? Which surfaces? Which matrix? A lot of questions that still remain unanswered, right? So we started from scratch. That's when we started involving practitioners, of course, not only at the question phase of the project, but also at the which samples, which surfaces should we collect, right? In the end, we came with a lot of surfaces that we thought they were important just because of high frequency of contact perspective, but also those that may help disseminate the virus, right? So we ended up coming up with a list of 29 potential samples per farm, right? But then we targeted specific farms, right? At the time of this conversation, L1C 0.5 was just burning, like if it was burning through wood, right? It was just infecting farm after farm. So we said, let's go and find positive farms. We were able to find 7 that were kind of handy, close to our campus. But then we also wanted to make sure that we were not missing certain things. We chose 1 negative farm in the epicenter of this outbreak, just to see if we could get a feel for comparison, right? Interestingly enough, at that same time, a team from the CDC was doing something similar with COVID in households where there was at least 1 individual positive for COVID-19. And they were using swabs, right? They were swabbing the nightstand, the pillow, et cetera, et cetera. So this kind of made us feel good, right? In the sense that we're not crazy. This is kind of doable. Because at the end of the day, what we're trying to do here is trying to put some more pieces to that mechanistic process of transmission, right? So what was our approach? So Marcelo, he pretty much drove around the state. He may have driven around the state way more than I have in my 10 years here. Basically is, he just grabbed a resealable plastic bag. He put 20 mLs of PBS. He put a Swiffer-like gauze in there. He sealed that. This was all done at the lab so that it wouldn't get cross-contaminated. He would get to the farm, put some booties, coveralls, gloves, and start collecting samples. That's pretty much it, right? So for surfaces like that, he would do like a foot by a foot, pretty much 30 centimeters by 30 centimeters. It was a door handle. He would just try to cover as much surface area as possible. If it was the rating, again, 1 rating, specific rating. And of course, then he would go surface by surface, right? And I'm just explaining it very simplistic at this point, but I know that Marcelo is somewhere around there, or myself. If you have any questions, please come to us afterwards. At the end of the day, this was our end product. A gauze that was filled with some fluid, some particles, environmental particles, right? From which we could extract some fluid, right? Remember, we started with 20 mLs of PBS, or in the second project, this was a minimum essential media. Enough for us to submit to the lab, right? So very quickly, results from the negative control farm. That's the 1 farm in the middle of the epicenter while this outbreak was happening. All of the samples came back negative. So I think the practitioner from that herd was happy to know that on the outside, or the surrounding of his farm, he couldn't find anything. And I'm saying surrounding because we also did some particle deposition outside the barn, right? So we couldn't find anything outside. And of course, inside, because the pigs were PRRS free, they didn't find anything. So that kind of made us feel good in the sense that, okay, there might not be cross-contamination at this point. However, in the 7 positive farms, 143 samples were collected. It's not a rounded number because not in every single farm we were able to collect the same number of samples, right? Just because some surfaces were present, others were not present. All of them, except one, had at least one positive sample, right? Which I think is kind of, for me and for us, for my team, it's kind of frustrating in the sense that we have a PRRS positive population that is shedding virus like hell, and we can't find it, right? But at the same time, it's just disseminating throughout the state and throughout the country. So 19 samples, of course, 13% positive rate, that's kind of low. So like Dr. Lewerke said, do we have a good sampling strategy today? Well, you can tell us that we're missing something here, right? We picked it up, but it's hard to find. This is the range, so we went all the way from 1 positive sample to 8 positive samples in the herd. But look at those CT values, right? So this was related to the surface we were sampling from, right? And then 2 of those were further tested via viral isolation. We failed, we couldn't find it alive, so we said, okay, that's kind of a bummer, because that would have made us feel a bit better, right? That we were getting closer and closer to something. When we look at farm by farm and where those positive samples came from, this is the summary. Actually, this paper has been accepted. It should be published in the next few days or a few weeks, right? And you'll be able to see that summary there. But you'll see here 8 farms. The first one is our negative control. Then you're gonna have sow farm or growing pig farms, right? The number of samples collected and the number of samples that tested positive. And here you see the origin of the positive samples with their respective CT values. So as you can see, CT value is kind of high for the most part. It's kind of high. So we said, why are we not picking up that many viral particles, right? So in general, we said, okay, the exhaust fan cone, yes, there's gonna be dust. We know that from previous research, pigs will shed the virus, it'll stick to some particles, it will just get pushed out through the exhaust fan, right? No surprise there. One interesting one is we found it on the dirty side of the bench of a growing pig site. I was expecting to find it on the, on the dirty side of the bench, right? I think there was another one later on that we found on the clean side, which is the concerning part. Doorknobs, I guess if we're treating pigs, if we're moving pigs around, if we're touching a lot of dust, we're gonna contaminate ourselves, and then we're gonna contaminate our doorknobs. And then the mortality is led. If we're euthanizing pigs, there's gonna be a lot of blood spilled all over the place. And this is where we start thinking from a foreign animal disease perspective, I'm gonna contaminate these facilities really, really well if I start doing all these kind of processes, right? But the question kept coming up, you detected it, but you haven't proved that it's alive, right? Or alive or dead, I guess that's the discussion. Is it alive or viable? So we said, let's look at new technologies. And this is where we teamed up with Dr. Declan Schroeder and his lab, and with money from the AASB Foundation, we kind of replicated the same process in the sense that the one question that we wanted to answer is it viable? Is what we're finding viable? So Marcelo went ahead and he found 10 wean-to-market barns in the state of Minnesota and Iowa. But this time we were a little bit more picky in the sense that we want pigs that were clean at the beginning, so naive, coming from naive sow herds, that were not vaccinated, so that it wouldn't give us that kind of a false positive because of the PCR. We didn't want it to sequence as well at that time. But we also wanted to have recently infected populations, right? Just to kind of recreate that outbreak, that situation of the outbreak. So we decided not to go with too large of a sample size this time. We wanted to make sure that we could do a very good systematic approach in every single farm. So we collected 20 environmental samples. And we also wanted to get a feel for how much those pigs were shedding, that population shedding level. Is it high or is it low, right? So we picked we collected 8 oral fluids, roughly 16 pens. And this is the list of the surfaces that we approached, right? And we collected the sample. We said, okay, let's make sure that we collect samples from all these surfaces in all the 10 farms so that we can compare later on. What we did this time is we collected the sample. We kind of created, I think it was 2, 3, 4 replicates of the copies of the sample. We sent one of those copies to the UMN VDL. We're just going to screen those, right, and see what we can find there, right, via PCR. And then we gave another copy to Dr. Schroeder, right? The interesting thing is that he would run again his own PCR, but also he will conduct a viability PCR, which I think some of you heard about that technology yesterday in the ASF session, right? This one is the one we were interested in, right? Just to kind of get a feel for, I'm finding it, is it viable or not? Is it just in the process of getting degraded or not? So in essence, out of the 10 farms, in 3 of them, we were able to find viable PRRS, right? In which surfaces? In these surfaces, and these are the CT values, right? Again, I do have to make a disclaimer here is we collected 200 samples, right? 200 of those have already been screened via the UMN VDL PCR. Half of them have been screened by Dr. Schroeder's lab, so we're still in the process of generating this data. So interpret with caution, that's what I'm trying to say here. Let's look at the farms, right? One by one. I'm not going to go one by one, but I just wanted to get, I want you to get a feel for, again, during the summer, we're finding lots of PRRS. Again, I remember telling this to my MChimp participants. During the summer, we have roughly 250,000 cells breaking with PRRS. So this is the date when the practitioner detected PRRS in those naive groups of pigs. Remember, they came from a naive sow farm. This is when Marcelo was able to go to those sites. Here's pretty much the difference between those 2 dates. So Marcelo was able to get there within 3 to 4 weeks, right? So that's kind of early in the process, right? This is the results of the oral fluids. As you can see, more than half of those oral fluids were positive. So they were shedding. In some cases, they were shedding. I mean, we don't have the CT values today. He was able even to get a sequence out of those oral fluids, which is good. But now when we look at the tests by farm, this is VDL data, 20 out of 200. So 10% of the samples tested positive to the VDL PCR. I said, okay, we're still at that very low level of detection. What is it that we can't find it, right? Again, some farms will have more than others, right? So I'm sure that Marcelo at some point must be thinking, I drove around the state of Minnesota, the state of Iowa for a 10% positivity rate. Hey, it's part of research, right? But I feel like we're getting closer. Then Dr. Schroeder's PCR, which is different, and I hope he's in the room. Is Dr. Schroeder in the room? Good. I've got a lifesaver here in case I have a PCR question. It has different, it's got a, I mean, it's a PCR, I'm forgetting the word right now. Primers, thank you, primers. Different primers, right? Different primers that are targeting different areas of the virus, right? So look, out of the 100 samples that he has tested so far, 42 of them yielded a positive result, right? But again, once that's kind of, again, screening. Out of those 100, only 10 of them were viable virus, right? Just remember, we're in the middle of the process here, 10% of those samples. So when you see that you're finding viable virus in those surfaces, you say, okay, that kind of makes sense. That's kind of expected, right? Now, the thing is that, are we carrying that virus out? Very likely, right? But how much, right? And the other question that we have today is, are we carrying it outside and taking it to another site and then infecting some other pigs? That's the one question that we need to pretty much answer. Yes, there's some experimental data that if you go from infected pigs to naive pigs without washing hands or changing clothes, you're going to move it. But remember, on today's world, the individuals going from one growing pig site to another pig site might be 15 minutes, 20 minutes, 30 minutes. They may wash hands, change clothes. So that's something that we need to review. So just to close it up here, it was expected. We were expecting to find it, right? We were expecting to find it. However, we didn't. I was hoping we would find it a little bit more easier, and this is where we need to go back and perhaps think about other sampling approaches. Again, yes, it's coming out of the barn, right? It's just getting airborne. It's coming out, it's being pushed through exhaust cones. Of course, because there's so much dust, it's gonna settle there. So that was not a surprise. Still, we need to better understand this viability, right? Because if we're moving this virus ourselves, of course, we need to review our processes. But still, are we good at disseminating the virus ourselves? I still have a good question mark in there, right? I do know that a lot of companies are really focusing their processes in biocontainment, and that's good. This is a good training exercise if we ever need to go into a 911 situation. Because at the end of the day, I feel like we understand really well the direct routes of transmission, but we still have to understand the indirect routes of transmission way better. To close it up, I want to thank all the practitioners, the clinics, the producers, the production personnel that helped us with this. This was quite a lot of time, quite a lot of insisting of how should we address this issue? And I don't think I think we're moving forward where we still need to cover some more ground. The individuals from my team and students that helped with the sampling and those that provided the funding. So with that, I'll be more than happy to take any questions. Thank you very much.
Thank you, Cesar.